Hi all, welcome back to day 2, equations of linear and nonlinear functions. So last class we talked about linear and absolute value. And in order to be linear, which is what we did all first semester, they're either written in slope-intercept form, point-slope form, or standard form. Or the highest degree, the highest exponent in the equation is 1. Then we also talked about absolute value. An absolute value equation must have the absolute value bars. If it doesn't, it's not an absolute value equation. Today what we're going to be talking about is quadratics. And this is something we talked about before we left for spring break and kind of what we've been talking about the first part of this e-learning. So we're going to talk about quadratics today. So how do I know if something's a quadratic? Well, we know a couple different forms. We know standard form, y equals ax squared plus bx plus c. And we also know vertex form, y equals a parenthesis x minus h squared plus k. But what if they're not in one of those two forms? What do? Well, kind of like with linear, the highest exponent, highest degree was 1. With a quadratic, the highest exponent, and I'm going to abbreviate exponent as exp. And remember, highest exponent would be the degree of the polynomial. We will use that word more and more as we continue, equals 2. So when you look at an equation and the highest exponent, the degree of the polynomial is 2, then you know it's a quadratic. So let's look at the 9 equations down below. We already identified that 3, 4, and 9 were either absolute value or linear. Let's see if we can find any quadratics today. So number 1, the degree of that polynomial is 3. That's the highest exponent, so it's not a quadratic. Number 2, the exponent's a variable, not a quadratic. 3 and 4 we've already determined are absolute value and linear. Number 5, the highest degree, or the degree of the polynomial, the highest exponent is 2. So number 5 is a quadratic. Okay? So number 5 is a quadratic. Number 6, the degree of the polynomial is 2, or the highest exponent is 2. So number 6 is also a quadratic. And I'm just going to abbreviate quadratic as quad, like we did before in class. Okay, let's keep going. Number 7 has that weird root sign, so that's not a quadratic. And then number 8 has an exponent that's a variable, so that is not a quadratic also. So 1 through 9, the only quadratic ones are 5 and 6. Now we're going to evaluate them. Please, please, please be aware that when you're typing it in a calculator, you're going to want to use parentheses. And like we talked about before, this negative 5 is here. That's going to go in the place of every single x. So I end up with f of negative 5 equals 7 times negative 5 squared plus negative 5. It's really, really important to put that negative 5 in parentheses when you square it. If not, the calculator is going to do it in a different order. It's going to square the 5, then multiply by the negative. And we all know that negative 5 squared is positive 25. So just be aware because the calculator can do a malfunction there. So then we're going to do 7 times 25. And then we're going to add negative 5. And you should get 170. So we know that f of negative 5 equals 170. And we're done. Okay? So again, really, really, really pay attention to the negative signs there. That's where things will get a little bit confusing with that problem. And let's move on to number 6. So number 6, we also said it was a quadratic. Okay? And they're saying, okay, great. Now find where f equals 1. So I'm going to plug that 1 in for all of my x's. Remembering that the left side of the equation doesn't change. So I get f of 1 equals 7 times 1 squared minus 10 times 1 plus 2. I'm going to follow order of operations, so of course I'm going to square first, and 1 squared is just 1. You can do this all at once if you type in your calculator, or you can step it down step by step. 7 times 1 is 7, minus 10 times 1 is 10, plus 2. So because it's all order of operations, it's all adding and subtracting, we do 7 minus 10, which is negative 3, plus 2, which gives us negative 1. So f of 1 equals -1. So we're done. So we've already this week identified how do we identify a linear function, an absolute value function, and a quadratic function. Stay tuned on how to find an exponential. Have a great day, guys. Thanks for stopping by.